In this video, we are going to talk about chemical equilibrium. So I want to explain the concept of chemical equilibrium. I want to explain how to write the chemical equilibrium constant expression for Kc and Kp. Then we are going to look at what some vital calculations so you will understand how calculation in chemical equilibrium is being done. Simple calculation. So there are things you are going to look at in this video. So I will appreciate it more if you have your calculator, your pen, your notebook, so that you can follow through and take down every single thing. If you have any question, you can kindly leave it at the comment section. I will respond to that. So now when it comes to what chemical equilibrium is a dynamic process that occurs in a reverse reaction. And when we talk about reverse reaction, there is the reactant is producing the product, then the product is also reacting back to form the reactant. So we have something like this: A moving to what? To B, and B also reacting to what? Form what? A is called a reversible what? Reaction. And chemical equilibrium occur in what? Reversible reaction. Reversible reaction consists of what? Forward and backward what? Reaction. Now, before the reaction, there is the reactant is moved to what? To the product. Then the product is also moving back to what? To the reactant. So it's called a reversible what? Reaction. You get? So in a reversible reaction, we must have what? Forward and what? Backward reaction. So unlike when we have A moving to what? To B, this is called irreversible what? Reaction. A only react to produce B. B do not react to produce what? A. So in a chemical equilibrium, we are talking about a reversible what? Reaction. So now at first, or at the initial stage, we have more of the concentration of the reactant. Now as time elapses, the reactant start to decrease to produce what? B, which is what? The product. So as the reactant is decomposing or reacting to produce B, what will happen here? Now it will get to a stage where the B will also start decomposing to produce back what? The A. So at first we have more of what? Of the rate of A producing what? B. Now then as A is decreasing, the rate also what? Increase to produce one here. To get to a point where the rate at which reactant is producing the product is also the same rate in which what? The product is producing what? Back the reactant. At that point, we say the reaction is at what? At equilibrium. We say at equilibrium, the rate of forward reaction is equal to what? Rate of what? Backward what? Reaction. Now at that stage, we say the reaction is what? Is at equilibrium, and it's called dynamic what? Equilibrium. And the main reason why it's called dynamic equilibrium because they are moving. Get they not forward and backward but movements, but at the same what? Rate. That's why it's called dynamic what? Equilibrium. You get? So for every equilibrium reaction, we have called the reaction constant or the equilibrium constant Kc. Now when we talk about Kc, equilibrium constant in terms of what? Concentration, we also have what? Kp, equilibrium constant in terms of what? Pressure. We are going to look at each of this one here. So let's take what? Homogeneous what? Reaction. Now when we talk about homogeneous reaction, that is all the species, both the reactant and the product, they both have the same states. You have the same states. So we are going to look at what the gases. For example, if you have something like this, 2A gas plus what? 3B gas. Forward and backward reaction. You have let me just say 5D gas. So you shall be asked to write the equilibrium constant expression for this reaction. At first, for every reaction you are being given, you must check if the reaction is balanced. So if the reaction is not balanced, you must try as much as possible to balance the reaction. You get? Now, if you want to write the equilibrium constant expression for this reaction here, now we also have, you say that Kc is also what? Concentration of the product raised by what? Coefficients over what? Concentration of the reactant raised by what? Coefficients. You get? So the product are what? A and D. The coefficient are what? Balance. Sorry, the product is what? Is D. You get? Why the coefficient is what? Is the balance what? Mole. You get? Then for the product we have A and what? B. You get? The coefficient are what? 2 and what? 3. The balance what? Mole. So whenever I say a square bracket, it means what? Concentration. Concentration always with, now in chemistry we use square brackets to represent concentration, and concentration is what? Mole per what? Liter, or mole per what? Per dmq. You get? So that is what you want to do here. So now let's write for this guy. To write the Kc expression, so here we have Kc equals to what? We only have one product, which is what? D. So I would say concentration of D raised by what? 5 is okay over concentration of what? A gas raised by what? 2. The concentration of what? Of B raised by what? 3. You can see how easy it is to write the equilibrium constant expression for what? For a reaction at what? Equilibrium. Now this one is Kc. Kc means equilibrium constant in terms of what? Concentration. Is that okay? Now we have another one that is called Kp. So if you want to get it here, we have Kp equals to what? Now we are using what? Pressure. So the partial pressure for D, so you can see partial pressure for D gas raised by what? 5 over partial pressure for what? A raised by what? 2. Then partial pressure for B raised by what? 3. Do you see that? See, Kp is equal to equilibrium constant in terms of what? Pressure. So these are the two things you really want to master. Remember, we are looking at what? At the same state, gas. Now very soon we are going to look at what? The one for what? Maybe you have gas, you have solid, you have liquid. You are going to look at that one. But understand that let's start with the one with what? With same state, gas. So now let's start practicing the stuff. So now let's look at what this question here. You say write the Kc and Kp expression for the following equilibrium reaction. Look at the following reaction here. So if you know you can do it, you can kindly pause the video and do it. Then while I walk you around, check if your answer is what you are correct. You get? Pause the video, try it. You get? Pause the video and try it. Then let's see if you are going to get the answer. If you get the answer, just say I got all my answers. You get? So I just want to see numbers of people who are actually following this video. If you pause the video after I solve them and you got all the answers, so just indicate how many you got from this one here, right? So let's do it together. So here we have A. So look at the reaction here. So here we have 2NO gas plus what? O2 gas. Here we have 2NO2 what? Gas, right? So you can see that the reaction is what? Is balanced. The reaction is what? Is balanced. So you have Kc equals to what? Here we have NO2 gas. This is what? 2 over what? NO gas. This is what? 2. Here we have O2 gas. gas. This is what? Nothing. So that is what for Kc. Then Kp is equals to partial pressure, what? NO2 gas, about 2 over what? Partial pressure for what? NO gas is about 2. Then partial pressure for what? O2 gas is about what? Nothing. So that is it for the first one. You get? Here we have N2 gas plus what? 3H2 gas. Here we have 2NH3 gas. So if you want to write it here we have Kc equals to the constituent of what? NH2 gas. This is what? 2 over. Because what? N2 gas is about what? 1. Then you have H2 gas is about what? 3. Hope you are getting the answer. Because check your book now if you get the answer. Then you have Kp equals to partial pressure for what? NH3. So here is 3 gas. Here is about 2 over what? Partial pressure for what? C. Right? So Kc equals to constituent of C2 gas. Here is 1. So you don't want to put in 1 here over what? CO. Right? CO gas. Then here we have O2 gas. You get? Then Kp equals to same thing here. Partial pressure for what? CO2 gas. Oh wow. Partial pressure for what? CO gas. Then partial pressure for what? O2 gas. You get that? That is what for D. So here we have Kc equals to consider what? CO2 gas. This about 16. Here we have H2O gas. This about 18 over C. It's H18 gas. This about 2. Then we have O2 gas. This about 5. Get? So Kp equals to CO2, sorry, P CO2 gas. That's for what? 16. Then PH2O gas. That's for what? 18 over P C H18. This part 2 and PO2. This part 5. So you can see how easy it is to write equilibrium constant expression when the reactions are in the same phase, gas. What about if we have heterogeneous reaction, that is, they are not in the same phase? How are you going to write that? So that is next we are going to look at, right? I believe you got all this one here. So now let's look at what a reaction that has different states. So you can say that this reaction, we have solid, gas, and liquid. So how are we going to write this expression? How are we going to write the Kp and Kc expression for this reaction here? Now, when I take equilibrium constant expression, you don't use for what? You don't use the one for what? Solid and what? Liquid. You only use for gases, because that concentration is always what? Constant. You get? So you ignore them. Now, normally, if you want to write the Kc expression for this reaction, here you have Kc is equals to concentration of the B liquid raised by what? 2, right? Over what? Concentration of A solid raised by what? 3. Then concentration of C raised by what? 2. Now, but the concentration of liquid is always constant, so it's regarded as what? As 1. You get? So it's not going to be 1 raised by what? 3 over. Here, now solid is also the same thing here, so it's going to be 1 over what? 3 times concentration of what of C is for what 2. You get so anything raised to power 1 raised to power 3 is going to be 1. 1 raised to power 3 is going to be 1. So it's going to be Kc equals to 1 over what C is what gas raised to power what 2. So this is what Kc expression for what this reaction here. You want to write Kp expression, so Kp is going to be 1 over what partial product for what C raised to power what 2. That is it. So now let's try these two. If you can pause video and try for yourself. So once I'm done with tomorrow, you can cross check if your answer is what is correct. So I don't know question 2. Pause the video and write the Kp and Kc expression for what these two reaction. You get. I really want to see if you get it or not. You get, because most times you really want to try yourself before you see the final answer. You get. So that is the way to learn. Let's go over it again. Now let's look at it. So you want to write. You're looking at what the A. You want to write the Kc expression and Kp expression for this reaction here. So here we have Kc equals to. Remember, when I see a solid, it's always equals to what? To 1, right? Because here we have solid here, so it will be 1 over. This guy also what solid, it's going to be what 1 times. Concentration of this one is what gas, so it will be H2O gas raised to what 6. So it's going to be Kc equals to 1 over what H2O gas is for 6. So what about the Kp? Kp is simply 1 over what partial product for what H2O is for what 6. So that is it. It's very easy, right? Kc equals to, here's what gas, here's what it's gas. So between concentration of what NH3 gas. Here we have ACl gas over, and this one is solid, going to be what 1. You get, so my Kc equals to what concentration of what NH3 gas. Here we have HCl gas. So for Kp equals to what PNH3 gas, then PHCl gas. So that is it. So I believe now you have mastered writing Kc and Kp expression. Now let me move to the calculation aspects. So we'll take question 1 to display on the screen. At equilibrium for the reaction, the concentration of the reactant and product at 727 degrees centigrade will be found to be that SO2 is what 0.27 mole per liter. O2 equals to 0.40 mole per liter, and SO3 is equals to 0.33 mole per liter. What is the value of the equilibrium constant Kc at this temperature? So the first one to do, you want to write the reaction. So we should 2SO2 gas plus what O2 gas. Then here we have 2xO3 what gas, right? So if you want to write the Kc expression, so Kc is also what consider SO3 gas is for 2 what consider what SO2 gas is for what 2, we have O2 gas. Now from the question, each of these values you are already given to us. So concentration of what SO2 was given to me to be what 0.27 mole per what liter. Therefore what O2 equals to 0.40 mole per what liter, right? Therefore SO3 is equals to what 0.33 mole per watt liter. So what we want to do here is to substitute your value. You get, so So what do you want to do is substitute your value, right? So it's going to be SO2 is what? 0.33. So Kc equals to what? 0.33 or raised to what? Raised to what? 2 over, right? SO2 is what? 0.27, right? 0.27. So you have 0.27 raised to what? 2. Then O2 is going to be 0.40. You get? So if you know how to punch your calculator very well, you can just easily punch all these values into what the calculator and get your answer. You get? So Kc equals to. So if you punch one into your calculator, like use your calculator in solving it, I will not advise to do it one by one. I will advise to use your scientific calculator to get it straight. You get? So if you punch these values into the calculator, you are going to get 3.03. That is your answer. There is no specific words unit for Kc, so you can just leave it like this. You get that? So you can see how easy it is. When you consider a big unit to us, you can just easily impute our values and get it. Let's look at the second question. Look at what question 2. It will display on the board to consider the reversible reaction at equilibrium. Reaction there, the partial pressure are found to be A 6.70 atm atm, B 10.10 atm, C 3.60 atm. You get 3.60 atm. So you should evaluate Kp for the reaction. So if you look at the reaction very well, so the reaction is what? 2A gas plus B gas, C gas. So if you want to write the Kp, especially because we're talking about Kp, so Kp is equal to pressure for C. Anyway, it's not raised by anything, right? So over what? Partial pressure for A is what? 2. Then partial pressure for what? B. You get? So if you look at the form, if you look at it very well, the partial pressure for C was given as 3.60 atm, right? Partial pressure for what? For A was given as 6.70 atm. Then partial pressure for what? B was given as 10.10 atm. So what I want to do now is to impute your values here, right? So it's going to be Kp equals to, for C is what? 3.60 always per 1, right? Over, for A is what? Here we have 6.70 raised to 2. Then for 0.00764. You get? So you can either leave the answer like this, or you can express it in standard form. 1, 2, 3. So let it be 7.64 exponential minus 3. There's no specific unit for Kp, so you can leave it like this. So this can be the answer. So let's look at what question 3. Look at what question 3, which also display on the board. Say consider the following reaction. Consider the following reversible reaction in 3.0 liter container. The following amount are found in equilibrium at 400 degrees centigrade. Look at the following amount here: 0.042 moles N2, 0.5 mole H2, and 0.0357 mole of what? NH3. Calculate Kc. You get? So what we have to start off here. Now the mole of each of them was given to me. So volume of the container is equal to 3.0 liter, right? So here we have mole of what? Mole of N2 was given to me to be what? 0.50 mole, right? So sorry, here we have 0.042 mole, right? So mole of what? H2 is equals to 0.5 volts. 0.5 mole. Then you have mole of what? NH3 is equals to what? 0.0357 mole. So what I want to do here is to first of all calculate your concentration. You get? So because in solving what KC, you use the concentration, not mole. Now the main reason why they gave us the volume here, they want us to what? Get what the concentration of N to H and what NH3, right? Remember, concentration is okay, it's equals to what? Mole by what? Volume in liter or dm³, right? So the concentration, remember, we use square bracket for concentration. So consider what? N2 is going to be what? 0.042 mole over what? The total volume, right? The same thing here. H2 is equals to what? 0.5 mole over 3.0 liter. For what? NH3 is equals to what? 0.0357 mole over what? 3.0 liter. So what you want to do next is what? Use your calculation. Here we have N2 gas plus what? 3H2 gas. We have 2NH3 gas. So here we have our Kc equals what? NH3 over 2 over N2. Here we have H2. So you have to impute your values. You have to impute your values. This one is what? 0.0119. Yeah, 0.0119. Raised part 2 over N2 is what? 0.014 times H2 is what? 0.167 raised out 3. So what I want to do now is what? Use your calculator in solving it. Use your calculator in solving it. So you have 2.102. So that will be the answer. So we have done a lot of things in this video. How to write the KP and KC expression, and how to calculate this stuff here. So I believe you have gotten tons of value. I've got tons of value from this video. Please, if you are not subscribed to the channel, please hit the subscribe button, turn on the notification bell, and give it a like. If you have any question, also leave it at the comment section. You get? If this video is helpful, I really want to understand from you if this video is helpful, so I can produce more of this content for you. You get? If you have any topic for me, if you have any topic in mind for me to do, then you can leave it at the comment section. Probably I'll consider that I'll create a video just for you. Now the main goal for this Chemicals TV is to, you at your own comfortable time, you can also study. That is the essence of Chemicals TV, right? You can also recommend this channel to your friends and your classmates so that they can be aware that there's something like this that will help them in their study, so that they can do well in their personal exam. So please subscribe. See you in the next video. Thanks for watching.